Trajectories of moving objects are of interest in multiple research fields. Retrieving similar object movements can give insights into movement patterns. We propose a similarity measure considering particle shape and orientation. Firstly, all trajectories are resampled, then movement parameters are computed for the trajectory shape and particle orientation. Relevant trajectory paths are identified, and for each of them symbolic representations are calculated. Finally, a similarity score is computed. This algorithm allows the user to filter a dataset consisting of a huge amount of particles for a given query trajectory, considering both the trajectory shape and particle orientation. This is helpful for applications where the object orientation influences the movement behavior, like in this particle simulation. The query is performed in a progressive manner, showing only trajectories with matching paths in the end. The interactive exploration showed that similar particle movements exist.
In our paper, we addressed the challenge of automatic segmentation of computer tomographic scans of ancient clay artifacts. These artifacts are built such that a clay tablet is fully enclosed by a protective envelope. The left side shows such an example. The blue depicted tablet is fully enclosed by a red envelope that protects the inner tablet and its content. We aim to provide a robust segmentation pipeline for domain scientists to enable the virtual investigation of valuable historical artifacts without physical destruction. Hence, we propose a pipeline that is capable of segmenting volumetric CT scans of earlier mentioned clay artifacts with minimal user input. Furthermore, we modified the compact watershed algorithm by Neubert and Protzel by defining a superellipsoid-based distance metric in order to adapt the algorithm to the shape of the objects. Besides, we propose a novel suppression-based pre-segmentation method that suppresses the intensity values of the distance transform at physical contact points between tablet and envelope.
We present WLD, a wavelet and learning-based line descriptor for line feature matching. The top left of the overview shows the original image, and the top right shows the multiscale pyramid of it, both with some line segments highlighted for visualization. The middle right depicts the wavelet convolution. The results are stacked together with the original RGB cutout, as shown in the middle left image. The cutout stack is the input to the ResNet, which calculates a descriptor. See the bottom left. This descriptor can be compared to other descriptors for matching, as shown in the bottom right. The images show matching results of our WLD in the top against the DLD and the LBD, which are shown in the bottom. To have a detailed look at the images, stop the video at any time. Thank you for your interest.
How to help developers and researchers of virtual and mixed reality environments in the analysis of user sessions. We propose a design and application space for visualizing data from virtual and mixed reality user sessions. In two examples, we show how visualizations from the different categories could be combined and used in one debugging and one evaluation scenario. Our design and application space can support systematic exploration of further advanced visualizations to explore user behavior and help to transfer ideas from related, more explored areas to this new area of application. While basic insights can be gained already by reusing existing approaches, our vision is to provide better support for developers and researchers through tailored visualization and visual analytics solutions.
Large high-resolution displays like this here are often one of a kind, built from a multitude of display devices and cluster computers. This heterogeneity makes it hard to run software tailored to one system on others, thus hampering collaboration. However, we believe that the advances in video encoding and transfer capabilities of modern GPUs should make pixel streaming a viable collaboration solution. In this talk, I will introduce a system that can be used for remote talks and other teleconference scenarios, and even for collaborative work on any application at the full resolution of the tiled display.
In this paper, we present a pipeline to recover grain boundaries from atom probe tomography measurements. represented as large, unorganized point clouds. The grain boundaries are surface-like structures that may intersect in a non-manifold fashion. In the first step, the user can tweak filter parameters for the point cloud and is presented with an interactive ray-marching-based visualization of the resulting surfaces. The boundaries are given by ridges in the point density. Then we propose a semi-automatic reconstruction method which generates the parametric representations of the visualized surfaces. We first cluster the filtered point cloud and compute individual surfaces for each cluster. In the final step, we recover the global, possibly non-manifold structure by intersecting the cluster surfaces and stitching them together.
Hi, welcome and thanks for tuning in. In the talk we will present our work concerning a multi-material hybrid component from structural mechanics. This hybrid was designed to connect metal with carbon fiber reinforced polymers and needs further interface optimization. For this, over 1,000 simulations were run and needed to be analyzed adequately. We therefore will present our methodology and talk about the application, its requirements, the visualization design, user tasks, and provide a discussion about limitations of current visualization techniques for tensor field ensembles despite their overall strength. Please join our talk and learn more about this interesting problem. Enjoy the conference and see you soon.
Even though high-dimensional reduction techniques can have good performance in 2D embeddings as seen in the left screen, the 1D embeddings often exhibit a much lower quality for pattern recognition tasks as shown in the right screen. We propose to overcome the issues by involving the user to take advantage of their experiences and expertise in pattern recognition tasks. The user can draw a piecewise linear curve on top of an automatic generated 2D embedding to get projected points on the curve to derive a 1D embedding. We can also apply this method to time-varying data by using an automatic tracking of the curve. Using a timeline view, we can detect the merging and splitting events of cluster structures. For more detail, please attend our presentation.
Markov chain Monte Carlo rendering, or MCMC rendering, generate a sequence of light paths to estimate light transport by iteratively mutating paths. MCMC rendering is known to be effective for complex geometry, but what if we want to render a scene containing small opening surrounded by the geometry? Unfortunately, the existing mutation techniques cannot efficiently handle this case, since the mutation depends on the edge perturbation around the path vertex. In this case, many of the proposed paths are rejected, making the highly correlated Markov chain. Now approach resolve this problem by allowing the edge perturbation rotating around a point in the middle of the edge, taken from the user-defined portal. Since the proposed path is less likely to be occluded by the geometry, the exploration of the path is drastically improved. For more detail, please come to our talk. Thank you.
In this work, we address the challenge of visualizing weighted memberships of elements in dynamic sets. In our approach, we use layered set intersection graphs. The graph consists of all non-empty set intersections as nodes, while the layered layout positions them in different layers. To provide different perspectives on temporal changes, we use a static view to visualize element set memberships for one time step, diff view to show changes between two time steps, and aggregated view for an overview across all time steps. Our approach offers in-depth exploration of dynamic sets to the level of individual elements. The interface includes a timeline to select the desired view, a degree distribution, an element list, and a rich set of interactions. For more details, stay tuned for the paper presentation at VMV 2020.